Well, I've now mounted the power supply that I showed in my first video inside a little metal box. It's the larger of the two power supplies. Here is the front display. This particular display is showing the output voltage, 13.6, and this one is an AC meter which measures the input current, voltage, and also happens to have a temperature probe as well. There's a few other little things on it, but the main things I'm using are the current drawn and the temperature. So just go in a little bit tighter. You have a close look at that. There we go. So we'll have a look inside. I've taken most of the covers off except the top one, so I'll remove that and we'll have a look inside the unit. I've got power on it at the moment. So here is a rear view. I've got a couple of XT60s outlets, female. I've got a circuit breaker which is 25 amps at the moment on the DC output, and I've also got a pair of banana binding posts which I use from time to time. The input is an IEC connector on a panel which also has an inbuilt fuse and an on-off switch. The actual power supply has an internal fuse which is normally soldered in, 6.3 amp single time delay. However, I've removed that, replaced it with an M205 fuse holder and put an 8 amp time delay fuse in there, and I've put the 6.3 amp time delay fuse inside this container so that it's easy to get to if something blows up. Here's a view of the power supply inside its case. Looking down on the top, you'll see a number of components here. We have a ferrite clip-on device on the mains input, and we have a DC filter on the output. The power supply itself is not bad. It contains a common mode suppression on the AC input, and also suppresses differential mode or common normal noise as they call it. So however, I've added this extra ferrite clip-on just to make sure. The DC output of the power supply does have some filtering, but it doesn't seem to have any common mode filtering, so I've added this common mode choke, which is 2 sets of windings contra wound on a piece of circuit board. The circuit board's double-sided. The bottom layer is actually in contact with the case and acts as extra filtering, normal mode or common normal mode noise type filtering. The choke itself provides the common mode filtering. This is a closer view of the back panel which shows the clip-on leads, the glide-ons. Right down in the far corner there's an earth bolt which consists of a bolt with 2 nuts, interlocking nuts, and the earth from the IEC connector and the earth to the power supply both go to that one spot. The DC output of the power supply goes through this circuit breaker. At first it goes through the common mode choke, and then the output of common mode choke goes to the output circuit breaker which feeds the connectors I showed you. They're on the back. This is a view of the inside of the front panel. You can see there the AC power meter which measures current, voltage. It also does power factor and temperature and can calculate how much energy you've used, although I'm not really using that part of it. There's a side view, and down here you'll see the earth bolt. It's a 4mm bolt with a couple of interlocking nuts on the inside. The earth wires are crimped to lugs, crimped and soldered and sleeved, so you've got to make sure the earth's nice and solid. The actual unit is held into the case by these screws here, 4mm screws, which pick up the threaded sections inside the case, and I've just used some little spaces here to make sure that I've got a little bit of room for the air to move for those slots. Here I've got it connected to IC706, powering it up. The unit has a fan. The fan runs very quietly without a load, but the moment you put a load on, it speeds up. So you'll hear the fan noise now. I've got the 706 on 7.15, and I'm just going to transmit on it into a dummy load. There we go. So I've got the 706 connected, and I'll just push the transmit button to RTTY into a dummy load, running 100 watt. You'll see the AC ammeter go up to 1.98 amps, and I'll just show you the RF power meter. So there's the RF power meter showing 100 watts into my dummy load. Power supply doesn't have any trouble with that. The voltage has fallen from 13.6 to 13.5. So there it is on 13.6. That's 13.6, no transmission, and 13.5, so it drops 100 millivolts with a 20 amp load on it. As far as the RF noise out of the power supply, it's actually quite clean. At the moment I've got the IC706 connected to the linear supply and this device is turned off. I do get some hash. I've got a little antenna on the IC706, just a bit of wire. I do get hash that comes from something inside the rig or nearby at around about 180 kcs there, up to 200, and then it's pretty good after that. So I'm just showing you that on a linear supply so we don't get confused between the hash that's coming out of the actual new power supply and what's already coming out of the IC706 due to other causes. So I'll just change the connector on the back. This is the linear supply, and this one is the one that is connected to the switch mode supply. Plug that in now. Turn him on. Turn on the power supply here, and this one here. And we'll do a bit of a scan. I'll just move the camera a little bit closer to the 706 so we can see the dial. There we go. So we'll still have our noise down here. We can't get rid of that. That's what we heard before. Now as we go up, I'll turn the volume up because there's not much to be picked up there. As I go through the broadcast band, there probably will be some weak carriers there. Not much really. So connect it up to the antenna. Yep. So I like that one there. Let go of the wire, bring it over to the power supply. So I can go all the way up, quite a long way, and not hear virtually nothing. So that's pretty good. I've got the power supply running the rig, and I've got a little 10 inches of wire not far from the case. That would be a spot which is a radio station, and so on. Now here at around 1.69 there is a signal from the power supply. I've got a clip lead on the negative of the power supply, and if I connect that to the case somewhere, you'll see that that disappears, and it depends whereabouts on the case. Now that's near the 240 volt side of the power supply, so it's picking up some noise from the case. So here's the clip lead. It's on the negative output of the supply before the filter. See, it disappears. There is another spugle that happens when I earth this part of the case, which is coming from this display device down there. So it's also generating a little bit of hash as well. So we have another one which is around 2.7 megs, which you can hear from this part of the case. So tuning around, this is 2 megs, there's not much at all, as you can hear. Little tiny bits here and there. Some of them come from the that little display at the front. I've noticed there's a few strong ones. When I say strong, strength 7 or maybe between strength 3 and 7. But as I go up the HF bands, the further higher I go, the less noise I get. So this one here on 2.9, is coming from the display. It peaks up around this part of the case. It's near the display. So the overall noise, once you get from 80 metres and above, I don't seem to see much increase at all with this power supply and the linear power supply. This is 40 metres.
Thanks for coming back to my call. Name is Simon, Sierra India Mike.
Oscar, November, and...
There you go.
The birthday's on the 15th of April, so there you go. But she went very quick, peacefully.
It's pretty good.
I think we've got the space blanket out.
Few signals on 20. They tend to stop when you're shooting them in.
Okay, cheers, Bill.
Hoping to catch up with Tony here shortly as we've got another
Operator Charlie Baker in.
There's some signals on 10 metres earlier today. Nothing now. Nothing on 6. It's pretty quiet. Power supply's not too bad.
Oh, what? Leave a message.
Nothing on 15. All these noises you hear on 80 are coming from other equipment. Solar panels and the NBN modem are quite noisy. They're worse than this power supply. So here I'm going to measure the ripple. I've got the probe on the input to the DC filter, which is the output of the power supply. So I'll just show you what it looks like on the crow. So there's the crow waveform. We're on 100 millivolts per division. I'm using a by 10 probe. So we're looking at around about 200 millivolts peak to peak. It's sort of about the right specification for this type of supply. Now I'll move the probe to the output of the DC filter and we'll have a look at that. Okay, so I've got to move both the positive and negative leads, not just the one. And there you see the result. So this is after the common mode choke. So I'll just move down to that part of the power supply. So here I have the by 10 probe on the output of the common mode choke. I've also connected the clip lead on the other side of the common mode choke as well, so that we're looking at the difference between the two. And as you could see on the crow, there was not the noise had gone way down. So here is the noise again, and I wind the crow up, and we're looking at 20 millivolts per division. So we're looking at around about 20 millivolts versus about nearly 200 millivolts. Quite a big drop in noise. Here is the same noise. It's now around about 50 millivolts. What I've done, I've turned the IC706 on. It's just on receive. If I go to transmit, I get a lot of RF into the probe. But turn the IC706 off. We're down to that amount of ripple. Turn it on, and we get quite a bit more. However, it's still quite low.